Today we're going to demonstrate you the TenTec Titan model 425 linear amplifier. This unit is specified for legal limit 1500 watts. It actually can do more than that. It has two triodes in parallel, 3CX800A7 from EIMAC, and each tube is actually good for 1200 watts PEP. So this will get you leisurely 1500 watts with about 80 well, 100 in some cases, but 80 watts drive power should get you easily 1500 watts. The unit consists of course of an amplifier unit. It is very roomy in terms of construction. It's much nicer built than all those units that have power supply and amplifier section in one box. That makes the amplifier section very cramped, and as a result you get a lot of arcing and other nasty stuff. You won't have that problem with this unit. It's extremely well built. TenTec also made stuff for the military, so that explains that the construction techniques that they used. Very professional. Now the unit has a power supply that is separate. Gives us 2500 volts at more than 1 amp, 1.5 amp I think. So that is separate. You can put that under your table. This is of course heavy, has a huge transformer in it, but the amplifier is not that heavy, so that can be on your desktop. Now we're going to load all the, we're going to dump all the energy in this dummy load, 2 kilowatt dummy load that is hooked up to the amplifier through a bird watt meter. A bird has a 5 kilowatt slug, so full scale is 5 kilowatt. And about here is where you will see the legal limit of 1500 watts. Of course it's all hooked up to my transceiver here, an ICOM IC9100, which we'll use as the driving unit, and the transceiver is powered from a Linko power supply. Alright, let's tune everything on. Turn everything on. We'll start at 80 meters. This is the band switch, a very heavy switch, all ceramic inside, silver ceramic, and then we switch it to the on mode. Now the transceiver has a wait function. I think it's 2 minutes specified by the manufacturer of the tubes. 2 minutes wait time required after the filaments are turned on, which is now. And the reason is that the tubes will last longer if you treat them like that. So this does that already automatically. You cannot use it until this wait time. So what we'll do is just wait till it happens. As you can see, we got load, we got plate, tune, as they call it. We got this is grid current. We got the voltage. We got that's the plate voltage. We got forward and reverse. There is a VSWR meter built in. And band switch is obvious. Once our wait time is over, we'll switch it to operate. If you switch it in standby, it basically stays in throughput mode if you want to transmit in low power, transceiver only. You can do QSK. This transceiver, this amplifier has a vacuum, killer vacuum relay, which allows you to do QSK for CW, very fast transmit receive cycle. And this of course is the power switch. Again, we have this in high power. The power supply is in high voltage. If I switch it to low, I get half the voltage, so then I get about 750 watts max, and the tubes will last longer that way. And this is our fan speed. You can put it in slow, but it's probably better to keep it fast. Unit is not very noisy, the fan. This is the air exhaust that needs to be unobstructed, of course. It doesn't make a lot of noise. If it sounds noisy on the video, it's probably worse than it is in reality. Alright, let's just wait till the LED goes off, the wait LED. Alright, we turned it on. As you can see, it's in standby mode right now, and the wait light is on. That means that we have to wait for the 3CX800s to be ready. That's according to the manufacturing specification. I think they want you to wait 2 minutes, maybe 1 minute after the filament power is applied. You saw it just went off, so we're basically ready to make some RF here. Alright, we got the unit tuned up at 80 meters. As you can see here on this radio, 3.8 megahertz lower sideband we have right now. As you can see, you want to keep the grid current low. And we're getting about 1600 watts right now, 1600 watts from the TenTec Titan. It can do more than that. The drive power we have is about 70 watts, 80 maybe. So you can get a little bit more if you push it, but I don't want to do that. And as you can see, it's very important that you keep the grid current low. We're here switched on grid current, and it is important to keep that as low as possible. And this is a very nice value for legal limit output. We have about 30 milliamps grid amp. That is extremely good. That means that the tubes work well. They have full gain and full emission. When tubes go bad, you need more and more grid current to get the full output, and that's not the case with this unit. So that works quite well. Obviously, we're now at the high voltage, so that's maximum output power. The fan runs at fast. You can switch it to low. It doesn't make much difference, so I just keep it at fast. High voltage means maximum output power. If I switch it to low voltage, it gives about 750 volts. That is then good for about half the power. So if you don't need maximum output power, it's probably a smart thing to do that, to extend the life of the tubes. But for maximum power, obviously you need to go to high. Standby operator, we're on operate QSK. We can do that as well. I now have it in regular PTT mode, and this is of course on-off power. As you can see, the units has the 160 meter band split in two, 80, 75, so basically 80 meters is so split in two, 40, 20, 15 and 10. It can do the walk bands, but with reduced power, but it is possible. Alright, we have it on 15 meters now, as you can see here, 15 meters. The transceiver is at 21.3, single sideband. Let's see what we get here. As you can see, I adjusted it for low grid current, very important. We get about 1.8 kilowatts here. As you can see, the tubes have good gain also at higher frequencies. That's again proof that they are in very good condition. And the drive power that we have is about 70 watts. It's about the same as what we had on 80 meters. 60-70 watts drive power gives us 1.8 kilowatts. So I could back it off a little bit. And so the gain is actually better than on 80 meters. And again, with low grid current. Very important to guarantee a long life for the tubes. Now what I will do is we'll go to 40 meters and I'll show you the tune-up method for the amplifier, and that guarantees you that you ultimately reach good output with low grid current. I'll now show you how to tune up this amplifier from scratch. So let's do that on 40 meters, bandwidth 40 meters. We're gonna put the transceiver at 40 meters. And we're gonna lower the power to the absolute minimum here. And I'll put it in FM mode because I need a carrier, constant carrier. Let's see what we're getting here. There you go. So I tuned for a little bit output power on the LEDs. Can maximize it here. Of course we're still very low power, as you can see. Not much output power. Now we're going to slowly increase the RF power. As you can see, we are increasing. Now you can see that my grid current is getting too high. So for that you back off your load. As you see, it has almost no impact on the output. So it's important to back off that load adjustment for minimum grid current. Here I'm increasing the power again and backing this off. We're now at 1.4 kilowatts, so I can give it a little bit more. Again, you back this off while I increase the drive power. We are at, well, I gotta keep this tuned as well. Keep the power in check. And here we are at about, well, I won't go much higher than this, 1.5 kilowatts with low. You see, this is already too high. Just go back, you will see hardly is an impact on the output, and my grid current is low, and I'm at 1.5 kilowatts, a little bit more for 40 meters, about 70 watts of drive power. And that's how you do that. Very important to start with low drive power, slowly optimize load and tune, and back off the load when your grid current gets too high. Keep that as low as possible. And if you do it that way, this transceiver will give you many years of service. As you might have seen from test reports, this is one of the better amplifiers ever made. It has a second order intermod of below 45 dB, below PEP, which is much better than all the Chinese and Russian crap you get nowadays. And it does that from two 3CX800A7 EIMAC tubes that are in parallel. They're triodes, ceramic triodes, and together they form an excellent combination. Very good linearity and good gain, and that is something you will not see in all those Russian and Chinese tubes. Thank you for watching this video.